Okay, folks. So we're going to go ahead and begin our discussion of trigonometry by defining the trigonometric functions in regards as being ratios. Remember, a ratio is a fraction. It's a comparison between two quantities. So let's begin with a map of the east side of town. Good times. And let's go ahead and study it a bit. So you have East Side High School over here. You have um, Avenue K right here. You have 30th right here, 20th right here. You have Avenue J right here. You have Walmart right here. Let's identify three locations on the map and label them with capital letters. So I'm going to go ahead and I'm going to pick, let's pick this right here. Call this A. This one right here. And then this one right here. I'll call this one B. And I'll call this one C. I'm going to go ahead and connect them. Ah, slippery. Forms a right triangle. B, let's discuss the corners or intersections of the streets that we have picked. So you'll notice that as far as we're concerned, this is where A is where 20th and J meet. B is where K and 30th meet. C is where 20th and K meets. However, you'll notice that if we actually walk on this triangle, if we actually walk the path that the triangle lays out, from A to C, we would be walking an actual street. From C to B, we would be actually walking a street. But from B to A, or from A to B, we'd be walking a desert in some parts. Okay. Now, the reason why this is called As the Bird Flies is because if you were a bird flying from A to B, you are bypassing streets, you're bypassing all that. You don't have to worry about jumping walls. But for our purposes, if we were to walk, essentially we'd be walking through desert. Okay. Part C. Let's discuss and define adjacent and opposite. All right. So here's how we're going to play this game. We're going to stand on a corner. Okay. Let's start on, let's start on corner A. I'm going to go and circle corner A. And let me ask you a couple of basic questions just to help you understand some of the terminology. What street, so looking at the triangle, okay, don't worry about anything else, just worry the triangle, right? The length AC is 20th Street. The length CB is Avenue K. The length AB is Desert. So if I stand on this corner of this triangle, the only street that I'm standing on is 20th Street, right? Because the other part of the corner is desert. So if I'm standing on this corner, the only street that I'm standing on is 20th. I'm standing on this street. And the street that's opposite of this corner is the only one that I see is going to be this street right here. This is the opposite street. So from the corner of A, the street that I'm standing on is 20th, and the street that's opposite me is going to be Avenue K. Another word for standing would be adjacent. So adjacent would be the street that you're standing on. Remember, from corner A is formed by AC and AB. The only street I'm standing on is 20th because AB is desert. If I'm standing on corner B, what street am I standing on? In other words, what street is adjacent to me? That would be Avenue K. Okay, and again, because corner B is made up by this segment and segment AB. AB is not a street. AB is desert. So Avenue K is adjacent. And what street, if I'm standing in this corner, if I look opposite or if I look across, what do I see? This would be the opposite street. This would be the opposite side. So if I'm on corner B, the adjacent street is Avenue K. The opposite street is 20th. Notice, so when I ask this question, I'm asking which street, not streets, which street am I standing on? Which street is opposite from me? Okay. Now you might be wondering, well, what about corner C? Well, what about corner C? If I stand on corner C, what street am I standing on? And I said, which street? Only singular, not plural. Which street? Well, the problem with that with corner C is that I'm standing on Avenue K and 20th. There are two streets. So we can't conclusively answer this question with one answer because the question only asks, which street are you standing on? On top of that, we run into another problem. Which street is opposite? That's not even the street. That's desert. So you see, standing on this corner on the right angle doesn't help us at all. Okay, we are not able to answer the question which street is adjacent or which street is opposite. One, because there are two streets that are adjacent to us, and the other reason is when I look opposite, there is no street. It's desert. Okay, so the idea of adjacent and opposite is relative to the corner that you're standing on. If a bird were to fly from one corner to another, what would be an appropriate name for that length? Well, if you look at this right triangle from A to B, that desert, we should call this a hypotenuse. So in other words, if I were to pick angle A as let's say angle B, okay, always pick a corner first. Based on this corner, this side would be my adjacent, this side would be my opposite, and this would remain the hypotenuse. Okay. If I instead picked angle A, then this would be my adjacent, this would be my opposite, and guess what? This is still my hypotenuse. So when it comes to right triangle trigonometry, we only pick either corner A or corner B. We never pick corner C to go ahead and set up ratios. Okay. So let's give some names to these ratios. There's this term SOHCAHTOA. The S stands for sine. The C stands for cosine. The T stands for tangent. And that's going to be opposite over hypotenuse. Its cosine is going to be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. So that's what we spent some time talking about the streets. You gotta know what corner you're standing on. You gotta know if the street is opposite or if it's adjacent, and obviously you gotta know where the hypotenuse is. You don't always have to make this A and B. You could switch them around if you want, but in this case, I'm gonna make them like that. We always, hint, important, you always label the corners with capital letters. The sides will be lowercase letters. The corresponding sides are going to be the ones opposite. So for example, if I have angle A over here, then little a will be across from it. Little b will be across from big B. And as is customary, we label the hypotenuse little c. So we're going to go ahead and start doing this officially. I'm going to start with A. The sine of A. This is how we write it. Cosine of A. Tangent of A. These are ratios. Okay, a ratio is a fraction, so I'm going to go ahead and make fractions sign dividers for them already. Sine of A is opposite over hypotenuse. So if I'm right here, the opposite side is going to be little a. The hypotenuse is going to be always little c. Notice how I say this, sine of A. Okay, not sin A, sine of A. This is a function, but we don't write it like in traditional function notation. This is not multiplication. This is a function. Okay. Cosine of A. Cosine is adjacent over hypotenuse. So what street am I on if I'm on this corner? I'm on B. Notice that these are streets, right? These are lowercase. These are not capitals. The capital letter is reserved for the corner that we're standing on. Cosine of A is little b over the hypotenuse, which is little c. And finally, tangent of A. Tangent of A is going to be the opposite from this corner, the opposite street, not the opposite corners, the opposite street, which is little a, and the street that you're on, the adjacent street, little b. Now let's do this again, but from B. So sine B, cosine B, tangent of B. I want you to try this out without me. So pause me. Set up sine B, cosine B, tangent of B without me. Pause me. Pause me. Okay, so sine of B, we have the opposite, which is little b, over little c. Cosine B would be the adjacent, little a, over little c. Tangent of B would be the opposite over the adjacent. Now, I'd like you to start noticing something. Trigonometry is what we call very cyclic, meaning that it repeats itself, and there's a reason for that. But you'll notice some patterns very quickly. You'll notice, for example, that these two are switched, right? Here's B over C, here's B over C. These two are switched, A over C, A over C. And you notice that these are actually reciprocals of each other.